I'm doing a short pitch on a CITS pilot that we did in the NPRA, Norwegian Public Road Administration. And it was actually based on that the NPRA has conducted several ITS pilots, and we reused some of the infrastructure that we already had in those pilots. And we try then to connect that infrastructure to our DATEX node. So the goal for that pilot was to demonstrate the day one service using then the ETS G5 carrier. And we have selected some categories from the SRTI messages that confirms to the C-road specification. What we would like was to demonstrate that we can, in real time, provide data from moving vehicles, both from using the CAM and DENIM protocols, and actually deliver a payload to our DATEX node using an ordinary situation publication. And we, of course, use the TISA specifications for the mapping from SRTI messages from DENIM to DATEX. So that's what this short pilot is all about. The parts involved from the DATEX 3 standard are the more or less the ordinary parts, part 1, 2, 3, and 7. And we, of course, use the situation publication as a base. We also created a very simple version of the exchange because at the time we did this, the exchange specification was not completed. And we also provided a custom profile based on the recommended reference profile for SRTA. All the SRTI messages are listed here, the safety related traffic information messages, and those marked with a star here was the ones we would like to test to receive information from. Some of these were made by simulating it using an app, and some of these were actually conducted by real equipment installations in a car. So I'm going to show those two that we have installed equipment in a car. One using the temporary slippery road, and the other one for the wrong way driver. So our setup was then to reuse some infrastructure from already conducted ITS pilot projects in the NPRA. This is from Europe Road number 6, big crossing in south of Oslo. And what we would like to demonstrate was how we could get the wrong way driver notification when the system detected that a car was driving the wrong way. And we also wanted to test the slippery road, temporary slippery road. And we already had the ITS server. So what we did was to modify it to actually also provide a payload using DATEX 2. And we also call this an automated situation because it were provided automatically, not registered by hand. We created a new interface on our DATEX node, and we then reused the whole infrastructure we have for DATEX. Then we also used our internal web client to actually see that we got that publication into the DATEX node and can read it out again and show it on a map. So the temporary slippery road, the first one. Here we used a setup in a car. We had this OBU, the onboard unit, connected to the computer unit in the car using the OBD port for CAN bus communication. And then we read out the parameters for speed, runs per minute in the engine, and the ambient temperature that the sensor in the car provides. And then we sent this via the G5 to the roadside unit, as viewed here in the picture. So we have the OBD in the car, then the OBU unit in the car, send the denim message to the RCU, which again triggers the mapping in the ITS server and provides the weather-related condition, which is ice. So ice on road then transforms to the DATEX element, weather-related road condition, which and then ice. As you can see here, and this resulted in that we can see ice on road as a denim message in the ITS server, and then we can also see that this is partly Norwegian, but the event type that is detected on the same spot here is ice in our web client that consumes the DATEX node publication, as you can see. The next one, the wrong way driver, that was based on CAM. So then the car and the OBU unit in the car sends CAM messages, and then the RCU was programmed to detect the wrong way driving direction, and then trigger the denim 14.0, which is wrong way driving, which is then translated to vehicle obstruction and vehicle on wrong way carriageway in DATEX. And the way this was done was to actually then mark out a geofence on one side of the road. This is actually the correct way of driving, but we couldn't, of course, stop the traffic, so we detected the wrong way, actually the right way. But when the car moved into this geofence here, it was detected as a wrong way driving. As you can see here on the left, the blue geofence is actually the area where we detected whether the driving was the wrong way in this case. And also we made another sample where we used some wider geofence rectangles, and these combined, when you drive in this direction, also triggered the wrong way driving direction. Again, we could see this in the same map. Here you see then the wrong way driving, then the message 14, detected on that section, as you could see, where the blue geofence were. And then again, we received also a notification through the DATEX publication and our web client, the DATEX message vehicle on wrong carriageway at the same position.